Okay, for our next lesson for Stage 1 Chemistry, we're going to explore atomic symbols and basically how we represent the atoms that we always deal with. So by this point, I'm hoping you all realise that each of the atoms has an individual symbol. So C is for carbon. If we start from the start, we have H for hydrogen, He for helium, Li for lithium, Be for beryllium, B for boron, C for carbon, N for nitrogen, O for oxygen, and so on. So we have these atomic symbols which we use to represent each atom. We want to take that to a little bit higher level though now. I've put these two links to simulations, PhET simulations up on Edmodo, and I hope that you've had a look at these two and had a play. There's some games there that you've just played around and got a feel for how the structure of the atom in the Build an Atom one, and what isotopes are, and the concept of atomic mass also in the isotopes and atomic mass simulation. So if you haven't done that, I'd recommend that you pause the video and go and do that now. But if you have done that, let's get on with the story if you like. So there, as well as the atomic symbol, there are two important numbers that which we usually write here to the left of the atomic symbol, one at the bottom, one at the top. The one at the bottom is the atomic number, and that tells us the number of protons. So this one, by telling us the number of protons, it's telling us which element. Because if that was 1, it would be hydrogen. If it was 2, it would be helium. If it was 3, lithium has 3 protons, so it'd be lithium. If it was 4, it'd be beryllium, because beryllium has 4 protons, and so on. So carbon has 6 protons, so therefore that number is 6. So in a sense, we don't need both of those, but we do write that for completeness. Now the number here at the top is the mass number, and this tells us about the number of neutrons plus the number of protons. So in this case here, if this says 13, we know that carbon has 6 protons, so therefore 13 minus 6 is 7, or 6 plus 7 is 13. So this isotope of carbon must have 7 neutrons. Why is this important? Well, this is important because elements can have different isotopes. Actually, I haven't put a definition for isotopes here. I probably should. Isotopes of an element have the same number of protons, but different numbers of neutrons. So not every element will have the same number of neutrons. They can have different number of neutrons, and where they have different number of neutrons, we refer to those as isotopes. Might just pause for a second and actually write that definition on the notes. So isotopes of an element have the same number of protons but different numbers of neutrons. So this is carbon 13, that's one isotope of carbon. We could also have carbon 12, which would have 6 protons plus 6 neutrons, or we could have carbon 14, which would have 8 neutrons plus 6 protons. Sorry, I've done them the wrong way, opposite way around, but hopefully that's not confusing. So we need to be able to represent isotopes, and we do that using these symbols. The other thing we need to know is that isotopes have different physical properties, e.g. their density. So because of the different numbers of neutrons, they'd have a different mass, but they have identical chemical properties. That means they react the same in chemical reactions. And really, that's because in chemistry, it's a very superficial science. It's what's on the outside that counts for chemical reactions. Atoms tend to react with the outside of other atoms, and what's on the outside of atoms is electrons, and the number of electrons is related to the number of protons, and it's not related to the number of neutrons. So changing the number of neutrons has no effect on the way an atom will react chemically, therefore it has no effect on its chemical properties. That's all. Thank you.